We're going to look at a compound now that has a double bond. We're going to look at the compound C2H4, and carbon is going to have 4 bonds, but there's only 2 hydrogens for each carbon. This is the compound ethene. And so in order for carbon to have 4 bonds, there must be a double bond between the 2 carbons. Hydrogen can only have 1 bond. What this means is the geometry of this particular carbon and this particular carbon individually is trigonal planar. You should remember that trigonal planar geometry means sp2 hybridization because we have 3 electron groups. I'm going to label these with some new terms. I'm going to label these bonds a little different than we have in the past. This particular bond, I'm going to give a name, and this is what we call a sigma bond. And these 2 bonds are also between carbon and hydrogen. Those are sigma bonds. This bond up here is different. It is what we call a pi bond. It's different because we are only allowed the sp2, that's only 3 orbitals for that carbon that are the same, and that's 3 sigma bonds. So one of them is going to be a different kind of bond, or a pi bond. So let's do carbon in its ground state, its excited state, and then in its bonded state. We're going to look at just the second energy level. So we have 2s and our 2p. There's 2 electrons on the 2s and 2 on the 2p. We're going to need to promote one of these electrons up to the 2p. So he's going to get promoted right up here. And of course, this requires energy. Now, that is the same thing we saw with sp3. But in this case, we don't have sp3 hybridization. We are going to have hybridization, but it's going to be different from what we've seen before. Not every one of those electrons is going to be hybridized. Only these 3, because we're looking at sp2 hybridization. So now, when we hybridize, and we want to draw these in between, this is going to be sp2, and one of these p electrons is going to remain on the p orbital. So that's sp2, and this is 2p, the one I have left over. And here are my 4 electrons. 3 on the sp2, that gives us the trigonal planar. Now I'm going to bring in my hydrogens. And I'm only going to look at 1 carbon in this case. The other carbon would be very similar. And I'm bringing in my 1s electrons from the hydrogen that are going to bond right here and right here. Those are going to be my sigma bonding electrons. So those are sigma bonds. Now I've got 2 other orbitals left. That's going to come from the other carbon. So if I want to look at my other carbon, it's going to be the same. It's going to have that same arrangement as the carbon we're looking at here. So what's going to happen is there's going to be overlap between this right here, that orbital, and this one's going to go up to here. So we get bonding that way. But they're different kinds of orbitals. This bond right here is going to be, again, a sigma bond. The unhybridized orbital is going to be our pi bond. That's that second of the double bond. This sigma is going to be the first of the double bond. So this right here is my other carbon coming in and bonding with the carbon we're looking at. So sp2 hybridization gives us a trigonal planar, and of course this carbon is also trigonal planar.